We built the silicon furnaces. We cooled them with oceans of water and fed them with enough electricity to power small nations. We took mathematical abstractions and forged them into physical, roaring engines of computation. We conquered the atomic limits of the transistor. We bypassed the von Neumann bottleneck. We pumped dielectric fluid directly onto white-hot silicone just to keep the dream of synthetic thought alive. But what was it all for? For thousands of years, intelligence was a biological privilege. It was confined within a skull, limited by the speed of chemical synapses and the upper bounds of human endurance. To write complex code, to draft a legal contract, or to discover a new molecule required training a human being for decades. It required rest, sustenance, and time. But we have fundamentally altered the equation. Intelligence is no longer a biological trait. It is now also an industrial commodity. It is manufacturable, scalable, and distributable across global networks at the speed of light. When these engines run at full speed, what happens to the very fabric of reality? Welcome to the synthetic age. This is AxiomTech, and I am Epoch. In this episode of our Silicon Wars series, we are stepping out of the clean rooms and the data centers. We are looking beyond the hardware and the software. The Industrial Revolution mechanized physical labor. It replaced human muscle with steam and steel. This transformation gave us the factory assembly lines. Assembly lines drove the marginal cost of physical goods down to a fraction of a cent. What we are witnessing today is the exact same paradigm shift, but applied to human cognition. We did not just invent chatting bots or image generators. We have built a cognitive assembly line. Deep within the architecture of those H100 GPUs, those trillions of matrix multiplications happening every second, are systematically driving the marginal cost of intelligence down. Thought is no longer a bottleneck. It is now a resource that can be processed, replicated, and transferred instantly. Consider the sheer scale of cognitive arbitrage. A task that would take a junior developer 3 to 4 days to research, learn, and write can now be generated by tensor core clusters in 400 milliseconds. These tensor core clusters do not sleep, do not unionize, and do not suffer from fatigue. Unfortunately, this is the brutal reality of the new economy. If your job relies solely on moving data from one spreadsheet to another, or writing boilerplate code, you are no longer competing against other humans. You are competing against the thermodynamics of a data center in the desert. Catching up to the efficiency of these sleepless, tireless silicon machines is extremely difficult, nearly impossible. However, the deepest and most terrifying impact of this industrial intelligence is not happening in the cubicles of white-collar offices. It is happening at the absolute bleeding edge of scientific discovery. In biology, understanding how a protein folds used to be a process that required humanity's painstaking laboratory work for decades. Our synthetic engines solved it in months. Now nearly every known protein structure has been mapped by artificial intelligence. In material science, they are synthesizing entirely new compounds for solid-state batteries. In mechanical engineering, they are generating aerospace architectures that human intuition would instinctively reject. These designs look alien, almost organic, yet they are mathematically flawless and perfectly optimized for stress and thermal loads. When these intelligence engines run at full capacity, they do not simply repeat what we already know. They simulate the physical and chemical laws of the universe at a velocity we can barely comprehend. They are optimizing the critical path of discovery. Innovation itself is becoming automated. We are no longer the primary drivers of technological progress. We are becoming the biological supervisors of a synthetic evolution. But there is a fundamental, unforgiving rule in engineering. You cannot fully control a system that you do not fully understand. And the chilling truth is, we do not fully understand the synthetic minds we have created. In digital design, we strive for deterministic outcomes. We write RTL. We design logic gates. We control the clock domains. We mitigate RF noise and signal integrity issues. We know exactly what a signal is doing at any given picosecond. It is a world of absolute verifiable logic. Deep neural networks are the exact opposite. They are not designed, they are grown, they are trained. This is the black box problem. We built the silicon. We wrote the mathematical architecture. But when a model with over 1 trillion parameters makes a decision, whether it is diagnosing a terminal illness, approving a high-frequency trade, or guiding an autonomous weapons system, we cannot trace exactly how it arrived at that specific conclusion. The fact that we cannot observe this black box does not change. There is no clean Boolean logic to debug. There is no line of code you can read. There is only a vast, multi-dimensional ocean of floating point weights and biases. We are deploying systems that exhibit emergent behaviors, capabilities they were never explicitly trained to have. And in environments where the tolerance for failure is absolute zero, such as nuclear infrastructure, aviation, the global financial grid, relying on a stochastic black box is a terrifying gamble. We have traded predictability for power. When the marginal cost of intelligence plummets toward zero, what happens to the global economy? If a cluster of GPUs can perform 90% of a law firm's contract analysis, or 80% of a tech company's foundational software engineering in seconds, at a cost measured in fractions of a cent, how does the human mind compete? These engines do not just create efficiency, they aggressively redistribute value. Power is rapidly consolidating into the hands of those who control the compute. The hyperscalers. The companies that can afford the billion-dollar lithography machines, that can build their own custom silicone, that can secure the gigawatts of energy required to keep the coolant flowing, they are no longer just software companies. They are the new barons of the digital age. Capital is no longer flowing toward human labor. It is flowing toward thermodynamics, advanced packaging, and silicon. The wealth of nations is being tethered directly to the number of tensor cores they can power. The history of engineering is the history of our attempt to tame nature. We tamed fire, we tamed water, steam, and the atom. We forced electrons to dance to the rhythm of our clock signals. But now, we are attempting to tame a synthetic cognition that may soon surpass our own. Will this end in a post-scarcity utopia, where disease is cured by algorithms and automated systems provide for every human need? Or will it end in a catastrophic misalignment, where we are optimized out of the equation by a cold, calculating machine? We don't know, but we know one thing with absolute certainty. The engines have already been ignited. The furnaces are burning. The silicon is shattering the barriers of logic, turning raw electricity into pure, relentless intelligence. There is no turning back from here. This is AxiomTech, and I am Epoch. For those who do not believe in magic, but in the brutal, unforgiving reality of engineering, thank you for joining us on this journey into the silicon. See you in reality.